Welcome to session 5 of our gas welding. In session number 4, the previous session, we went into gas bottles and how to set the regulators and the pressures and how to set the diaphragm and so on, checking for leaks and all of that. You may want to refer back to session 4 if you're just dropping in for this welding. We'll start with our settings, which in this case are 3 psi, approximately 3 to 4 psi on both the oxygen and the acetylene. To begin, this is a striker. We will open up the acetylene, the red line valve, just slightly, and we now have a flame. And the goal here is to move the flame slightly away from the tip and then bring it right back to the tip. We're striving for a neutral flame in this case. And with the tip hot, we'll slightly crack open the oxygen, very lightly, until we bring the cone of the flame down to a neutral, and that's this point right here. This would be carburizing, more carbon or acetylene. This would be oxidizing, an intense point with high oxygen content. In this session we'll start welding. We're going to use this 16 gauge coupon plate, sheet metal if you will. Our filler rod in this case for our very first project will be ER70S2. It's a fairly high tensile, that's a 70,000 tensile filler rod that has good properties for working with clean metal in particular. And of course we have our torch set up with a number 2 tip. Let's get started. Let's do this again. We'll light the torch from scratch, crack open the acetylene slightly, there's your flame. Flame goes out, comes back till it's just even with the tip. We open the oxygen, bring it into a neutral flame, which is right here. This is an oxidizing flame. Can you hear the oxygen? See the sharp point to the cone? Take it right back out to here. That's carburizing, and that's a neutral flame. That's the appropriate flame for this ER70S2 rod, working with these coupons. We'll get suited up here, get some protective gear on, and get started. Again, we're going to make our neutral flame and not let the acetylene burn for too long or you'll end up with soot all over your shop. I've cut the ER70S2 rod in half so it's more manageable. And what we'll start with is a tack weld. The idea here is you can easily get into too much gas, so if anything, drop your pressures down to 2 psi. I'm running about 3 here. This is plenty of heat. These plates will heat up very quickly. And the idea is to put a controlled amount of heat to the 2 parallel pieces here and watch the coloration of the metal until both sides are equally red and about to puddle. And when they are starting to puddle, add your filler metal, dip it in there, and there's your tack weld. I'm going to do something a little unusual here, but it's for illustrating the process better. I've dropped my pressures down too, by the way, to 2.5 on the acetylene and about 2 on the oxygen. We don't need to waste gas or create more heat. And what I've done here, I've set the plates or coupons 68 thousandths sheet. We're calling it 16 gauge, measures 68 thousandths of an inch thick. I've set it on a 45-degree angle to better illustrate what we're doing. I'm going to even hold the torch awkwardly on an angle like this because I want you to see what goes on with the puddle, what we're actually trying to accomplish here. When that metal liquefies and we actually have a puddle, and you notice how far back I'm holding the torch, at that point then we'll introduce the filler rod, and not before then. We want liquid. And technically you should be able to fuse these 2 pieces of metal without even introducing the filler. And that's our goal here, just to illustrate what the puddle does and what the fusion of metal is. Keep that torch tip away from the metals, liquefy the puddle, get it to flow together. That's actually a tack weld there. We're going to make a few more tacks without the use of the filler rod. Again, I think it's useful for you to see how we can control that puddle with heat, that it isn't about adding metal as much as it's understanding how the metal liquefies and flows together. So let's do a couple more tacks, and we're not going to use filler. I'll come from this end. Probably easier for you to see. And watch how we control the molten metal flowing on both sides. Pull the heat away a little bit. There we go. There's a tack. Again, uniform heat on each side. Flame is slightly oxidizing. Let's add a little bit more acetylene. Keep the cone away from the metal, where you will have flashing back and popping at the torch and scare the hell out of yourself. So again, heat both sides uniformly. Don't overheat it. Starts to liquefy. Get it to flow together there. You see that? That's what we're after. That's a tack weld without filler. We'll do one more. Pay attention again to the coloration of the metal. Uniformly on each side. We want to get it to flow together. There it goes. And that's a sufficient tack weld without the introduction of any filler metal. Now we'll let the metal cool down completely. We've got tacks on both ends, these 3 intermediate tacks, and we'll run a bead straight across that. The plate is actually warped. There's warpage because we didn't hold it flat. There's a high amount of heat. This metal is fully fused. You could actually flatten it with a hammer if you had a need to do that, but we're going to run that bead all the way across here using filler rod and just move on to our next welding, and that will be running a bead in session 6.